In this second video, we are going to have a look at the transformation of graphs when x or f of x are multiplied. So basically, we are going to combine f with the function h, which maps x onto 2x. So here you can see that f combined to h in the first case is 2x squared minus 2 times 2x. We just change the x we have here and there for 2x. So this is f of 2x. And the second one is the combination of the same two functions but in the other order. So f of x is x squared minus 2x, and all of this is multiplied by 2. And so here we have 2f of x. So you see that here x is multiplied by 2, whereas here f of x is multiplied by 2. Once again, we are going to plot the graphs for these two functions. You see that we're using the same value tables as in the first video. And let's now have a look at f of 2x and 2f of x. Before we try and work out what's the value of this thing here, we are going to try and find out about 2x. So when x is minus 4, here we have minus 8. When x is minus 3, we have minus 6, and so on. You can complete the first row of your table just like that. And so what do we need now? Let's have a look at this value here, for example. We want the value of f of 2x. So when x is minus 2, 2x here is minus 4. So we want f of minus 4. F of minus 4 is something that we worked out in the first table. That's right there. So we know that f of minus 4 is 24. Similarly, f of minus 2 will be 8, as shown here. So we can complete this part of the table just like that. We don't really care about the values here because that would be out of the graph anyway. And all we need is to look at these values here to understand what's going on. So let's plot the graph corresponding to these points. Let's start with this point here. So we see that x is minus 1, and the corresponding value for y is going to be 8. So let's plot the points with coordinates minus 1 and 8. We end up right there. And if you wonder where this 8 is coming from, and remember it's the one we had here. So this point here is actually coming from this one, which was at minus 2 and 8. So it was coming from this point. So we've moved this way. For the next one, here, x is 0 and y is 0. So we have our point here that was coming from the exact same graph in the values table that was at the top. The next one there, x coordinate is 1, y coordinate is 0, so 1, 0 is right here, and this was coming from this point here on the graph. You see here that the 0 was coming from there, so our point has actually moved left this time. The next point has coordinates 2 and 8, so we have 2 and 8 right there. And this 8 was coming from here, and because this 2 has been multiplied by 2 to give a 4, so it's this point here that has become this one. So on the graph, it's this one here that moved this way. So you see that all points have moved in a different way. This one has moved to the right, this one has moved, and these two have moved to the left, but of different lengths. And if you look carefully, you will see that actually the length between the new point and the y-axis is actually half of what it was before. The distance was 2, now it's 1. Here the distance is 0, half of 0 is still 1. The distance here was 2, it's now 1. And the distance here was 4, and it's now 2. So the distance of all these points to the y-axis has been divided by 2. So you see what's going to happen to the curve. If you try and draw it, you are actually going to get a curve like this. This is what we call a stretch, an horizontal stretch with the y-axis as the invariant line with scale factor 2. from the value table here, you can maybe try and see what happened here. This point, this 0 came here, this 0 came there, the 0 here came here, and the 8 came there. So kind of show on the values table that you kind of shrinking this graph. It's a stretch with scale factor 1/2. So let's now have a look at the other function at 2f of x. So if you want to work out twice f of x, you first work out f of x, which has been done right here for all these values of x, and you just multiply the value by 2. So you will get the values 48, 30, 16, 6, 0, minus 2, 0, etc., etc. Let's try and plot these points now. This one here will fit on the graph. -1, 6 is going to be right there. And so you see, the first point was -1, 3 and -1, 6. So it's this point here that has moved up 3 units. For this one, you are still at 0, 0. For the next one, x is 1 and y is -2. So x is 1 and y is -2. For the next one, x is 2 and y is still 0. So you end up there. The next one here is at 3, 6. And the last one would be for 16. You would be way out of the graph. So your parabola ends up being like this. So you see this time, it's as if the black parabola has been stretched vertically. And what happens? You see that this point here has moved up 4 units. This point hasn't moved. This point here was actually coming from this one. So this one has moved down 1 unit. The next one here hasn't moved. And this one came from here, the point with coordinate 3, 6, 3, 3, sorry. This point right there. And so it has moved 3 units up just like that. So again, all the points haven't moved in the same way. Some that moved up, some have moved down, and it's never by the same amount. Again, you can check that this one was 3 units above the x-axis. It's now 6 units. This one was on the x-axis, so it hasn't moved. Twice, 0 is still 0. This one was at -1, but it's now at -2. This one is still at 0. This one was at 3, and it's now at 6. So it's now the y coordinates that have been multiplied by 2, which makes sense here from the equation of the curve. And what we end up with is the vertical stretch with scale factor 2. So let's summarize a little bit. If you multiply f of x by a number, you get a vertical stretch parallel to the y-axis for which x is invariant. And so all the y-coordinates of the points are multiplied by 2, which result in moving up above the x-axis and moving down below. But the stretch factor is 2, so this is something you could have expected from this too. Be careful though, because for f of 2x, we found out that the stretch is horizontal now because it's x that you're multiplying, but the scale factor is not 2, the scale factor was half, which explains why when you have to plot the graph of f of ax, the corresponding factor for the horizontal stretch is not a, but it's 1/a. Well, I hope this second video has helped you understand a little bit what we're going on with these multiplications. Good luck now for the practice. You can get plenty of it on GeoGebra. If you just look for my GeoGebra channel, my name is Mr. V, and you look for the graph transformation games, you will actually find plenty of little activities to practice the transformations of graphs.